And now what we will see next is Nicola talking about workflows and how to make them fair and sustainable, especially in Oslo. Okay, you can hear me right? Yeah. Thank you. And thanks for inviting me to present. So my talk is going to be about two kind of separate but related go back to the first slide. Two separate but related topics. So it's divided like this. So there's going to be a first part. We're going to talk about how to reduce environmental impact of workflow systems like Galaxy. And the second part is going to be how the third principles apply to computational workflows. So let's give it a start. So this, I think I don't really need to make you aware of this, but especially in this audience, but we have a climate problem, and this kind of a figure to explain, just took from one of the thousands of publications that's been recently about the increase of temperatures from the previous century, especially in the last years, is really increasing a lot. And what we can do as scientists to improve these, or at least to make it worse. So one issue is that we are more or less all in what we call ICT, and this has been having an increasing amount of greenhouse gases that we are emitting. So around 2-4% is the estimate that I found online, which is about the same as aviation, which is usually one of the bad boys, right? The aviation people. In particular, we are in computational research, and there's been some initiative already about how we can at least estimate what we are doing in that respect of greenhouse gas emissions. So there's two initiatives that I put there. One is the Green Software Foundation. They have published manifesto, and they have working groups about how research should, and particular software developers should approach these topics. And there's another one that's led by people in Cambridge and others, is the greenalgorithms.org initiative, where they have a carbon footprint calculator. And they also published a nice 10 simple rules paper, but always really popular, about how you can measure and not waste too much and produce too much gas emissions with your research. So why we should be interested in this in a Galaxy event? Well, if you think when you're running your tools or workflows in Galaxy, obviously these jobs go somewhere and they consume energy. And if you manage to reduce the amount of energy that you consume through your research in Galaxy, then we produce less gas emissions. And if you do it in a workflow system that is used by hundreds of thousands for research, and there's multiple installations, so you can scale the impact of your reduction of greenhouse emissions. So recently we started a EU project, EU Grand Horizon project a couple of years ago now, that has different topics, but one of these is also environmental sustainability. It's called Elixir Steers, and involves many 25 countries plus EPI, 38 institutes. So one of the objectives of this project is to have a toolkit for robust, reproducible, and green software and workflows. So the highlighted the part where we should concentrate for this talk is about green software and workflows. So going to a bit like work packages, tasks, etc. So this is what is actually about. The part of this talk is to make researchers aware of the environmental impact of your analysis and to avoid unnecessary computation by using what we call a job cache. So that's what I'm going to explain you about. There's also the environmental friendly job scheduling that was presented yesterday by Paul. It's also connected to this. So the first part was how to raise environmental impact awareness. So I don't know if I've explored. When you run any tools in Galaxy in your history, there's a I, like the letter I button, where you can get information for your job. So what you have run actually. One of the things that's shown there is how much, the CPU or memory you've used, showing a picture there. And from this number, so the amount of CPU and memory, you can calculate using certain formulas that are kind of best practice, how much energy this produced or I've needed, and in turn, how carbon emissions you have created. And so you can measure how many phones you could have charged with the same amount of energy, or I've been suggested in UK how many kettle you can warm up. You should add that as well. Okay, so what can we do instead of just showing the users what they've the impact of their analysis? So how can we, as a workflow system, can help them consume less amount of energy? So one thing we can do is to avoid unnecessary computations, for example. So the best thing you can do is not compute, so you don't produce energy if you don't compute. So when this can be happening, where you can optimize analysis. So one example is that tools that you run should normally, at least the large majority of tools, produce deterministic output. So if you run again the same tool with the same inputs and the same parameters, you expect to get the same outputs. So that's kind of standard unless you are in a situation where you have tools that on purpose produce random results or are not reproducible. And so Galaxy also stores all the information, what we call provenance information for a job. That means the tool, which tool you've run, which version of the tool you've used, what were the inputs and parameters of shown here. The Galaxy database has whole bunch of information connected with every single job that you run, in particular about inputs, parameters, and tool versions. So one thing that already I found out was 2017, 2018, so a number of years ago now, Marius, thanks for him to work on this, as the first people in the Galaxy project, introduced the concept of the job cache. So what we mean with that? So since we Galaxy track all this provenance information, you can actually, if a user rerun a tool with the same parameter input, you don't need to actually send the job to the cluster to recompute it. So if the user opt in, we have a showing there on the right, the additional options on the bottom of the tool form. Before you run your tool with the run tool button, there's an option, attempt to reuse jobs with identical parameters. That's exactly what it does. So if the user is opted in with this button, and the job outputs of the previous run are still available, so the user hasn't deleted them from disk, then you don't need to recompute if the user is using the same parameter, tools version, and inputs. And you can just link the previous result in the history with a new dataset, but actually there's no new data on this, no computing on the cluster or whatever, so you save both the energy of running the tool and also the storage space, and all your storage actually consume energy just for existing it. And this should be particularly effective if you're running a training course, for example, a large training course we do in the Galaxy community, like the Galaxy Training Academy, where all the trainees in the course are supposed at least to run the exact same analysis, starting from the same input, running tools in a certain order with the parameters that are specified in the training materials. So you don't need all of them to run the same job on the cluster all the time. And also, if you think this would actually allow you as a trainer to, normally when you prepare a training course, the first thing you need to do is to reduce the input of your training course to very small, or at least small enough to be run by a large number of people at the same time on Galaxy. Instead, if you reuse all the previous computation, you compute only one for the whole class, then you can use real-sized dataset instead of this toy dataset or toy example data. So this was initially implemented when Marius did the job in 2017-18, only for a single user. So if I run the same analysis again, then I will use it. But if someone else has done it, then I cannot see it as a user and I cannot reuse their computation. So the training example wouldn't work because we are all separate users running the same analysis. So we can think of extending it in various ways to make it available to more scenarios or use cases. So we have done a series of enhancements to the initial job cache. In particular, we have done many of these that I mentioned at the Biohackathon Europe last year, organized by Elixir. And one of the examples is the one that I made. So now you can also access, when you check for similar jobs, also the ones that are put in history that are public. So if the trainer of the course, for in this example, has made the analysis before to check that training material works and then make this history public, all the trainees can then make use of these previously computed jobs. And there's other issues in the previous implementation is that if different people upload the same data, then Galaxy consider this as different data sets and they don't match. And the way to solve this, so the next jobs wouldn't work. You wouldn't use the job cache. But if you calculate a hash of this data set that you uploaded, so a checksum style, just a long string to represent your data, then the job cache can now, or will actually still a work in progress at the moment and not merge. I'll put the pull request ID for each of these enhancements. They could just check the hashes. If the hashes of the inputs are the same, then they are considered the same data set and the job cache can kick in. And that's the kind of a bit more esoteric at the moment, at least, when you are dealing with deferred data sets. That means when you're not actually uploading initially the data set, just upload the URL of the data set that's resolved at job runtime. So that doesn't get loaded immediately to Galaxy unless you started using it in a tool. Then this case wasn't considered, and now instead also the deferred data set are actually linked using the hash when they are materialized. So future work for this part of the talk is we are having another Biohackathon project in Berlin later in the year, November. And the priorities that we have for this work is to ensure that the dataset are not modified after creation. So this is kind of a tricky point. If you're storing the data in like NFS and run a tool on a previous computer dataset, it could, in theory, be the case that the next tool modify this if you don't put if you make this dataset read only, if you have a malicious or coded wrongly tool. So we want to make sure this is the case that the datasets, once they are created, are never modified. Otherwise, basically invalidating the concept of the cache. And the other thing, we want to actually finish the pull request 19.1.2, which is the one about using hashes for inputs. And other things, we are not sure we're going to work on that. The Biohackathon plan is to allow tool developers to specify if a certain tool shouldn't use the job cache because they are actually creating random outputs or they are not reproducible for some reason. We want the tool author to be able to annotate the tools to not use the job cache. And we can also make more annotation for tools so they can apply the job cache in more cases that are currently not working, corner cases. Obviously, we want to do more testing and maybe consider to opt in, to make the user opt in automatically to the job cache and have an opt out still for people that don't want to use it. So that's kind of first part, and quickly move to the second one. So I suppose that most of you are familiar with the concept of FAIR. So it's an acronym for findable, accessible, interoperable, and reusable. And this concept was developed in 2016 and was about making the value and impact of data bigger. So if the idea is you can have data more findable, so the metadata are published and are easily to find and easily to access, and they can interpret, then you make them more reusable. So they increase the value of the data that you have produced with taxpayer money usually. And this concept keeps getting traction in the research community and extended to various fields of research. And in particular, in 2022, a new paper came out where they actually applied similar principles, so fair, but to research software. So they define things like that the research software should be published in repositories or registries to make that more findable. They should have a clear license that allow reusability. They should have versioning and all these kind of things that make fair applied to software instead of data. And the last year, or a couple of years, the new initiative started from the Workflows Community Initiative, which is kind of a group of like-minded people that work in different workflow systems all around the world and not restricted to any particular research field. And they formed a working group called the Fair Computational Workflows Working Group. And during various discussions, one idea came out to try to specialize or to apply the FAIR principles not anymore to data or software, but to computational workflows. So the first hurdle, even this is kind of a varied number of people from different sectors, was to define what we mean by a workflow. It seems easy, but when you actually try to formalize it, it's not that much easy. So what we came out was saying that it's a specialized kind of software, so it's still software which has special concept of handling multi-step data pipeline. So it's used to process data and it has multiple steps. So that's kind of the general concept. There is automation and reproducibility. These are the two things that workflows are useful for. So you automate your analysis, and it's also more reproducible if you formalize it in a workflow. And it also allows your workflow to make efficient use of your computational resources because there's more scalability and portability of the research. And often the workflow is made more high level and abstract by using a workflow language, even if that's not strictly mandatory. So that's the kind of the three main things that, or four things that we use to define what is a workflow. And we made examples that could be from very simple things like a script or a Jupyter notebook, could be considered in a way type of workflow, still multi-step analysis. But the usual thing would be running through a workflow management system like Galaxies, Make, Nextflow, etc. So what we did in this paper that I've attached there, the UI and the title, is applying the FAIR principle to computational workflows. We try to specialize this data and software, so both data and software principles to workflows, computational workflows. So a couple of examples, actually this is the list. So they're set up as guidelines, and the F1, F2, F3, blah, 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 for the findability, the A1, A2, etc. for accessibility. And I highlighted a couple of things they make a bit different from when you talk about software. So for example, we talk about components of workflow representing levels of granularity are assigned distinct identifiers. So the components of the workflow could be file, could be code, could be a sub-workflow. These are things that are not exactly the same for research software. We have different versions of the workflow should have distinct identifiers. And that's kind of maybe not special, but it's good. Workflows are quite a dynamic thing. You always keep updating your workflow. Another for findability is that metadata and workflow should be registered or indexed in a searchable FAIR resource. An example would be Workflow Hub or Doc-Store for workflows. The accessibility are very similar to the research software one, so I'm not going to go into detail. For the interoperability, we said that workflow needs metadata, you should use a formal, accessible, shared, transparent, and broadly applicable language for knowledge representation. So example would be CWR, WIDL, or Galaxy internal workflow representations, not exactly formalized, but we have the GX workflow format too, which is similar to the CWR language. Workflow is specified in a way that allows its component to read, write, and exchange data in a way that meets domain relevant standards. It is useful for portability of workflows. So you can take a workflow. The idea is you should be able to take a workflow from one research facility to another one and still be able to run it. And for reproducibility, for usability, components of a workflow representing levels of granularity are given clear and accessible license. So if you have a workflow that's composed by multiple sub-workflows, if you specify license for all of them, you allow, it could be different potentially, you allow the reusability of the sub-workflow outside of the full workflow. Okay, so what resources does Galaxy provide in that respect? So about having fairer workflows. I put a list from the top of my head here. So we know that Galaxy workflow are all versions. So when you save with your button in the workflow editor, then all the workflows get a new version. So we respect this particular principle. Galaxy is able to export the workflow and the workflow run as well as arrow crate, thanks to the work been done by Paul and others. And we also have way to access workflow that are stored in tool registry services from the GA4GA standard, TRS. We have best practice workflow panel. So if there's in the picture on the right, we are editing a workflow. There's a button called best practices that suggests things that help you, among the other things, also to make your workflow fairer. So it's like suggesting you if you haven't specified a license, if you haven't mentioned the author or other metadata, then it will suggest you fix to make your workflow fair. And then we also have places where we can share the workflow to make it more findable, like the IWC workflow library, where curated collection of community developed workflows are stored on GitHub. And these are, if you put your workflow there, then it will automatically upload them on Workflow Hub, Dockstore, and Zenodo. So make them even more findable and accessible. And there is also a training material topic on fair data, workflow and research that touch upon this and other things that you may track if you're interested in the topic. To conclude, we've looked at how we can increase the recognition and use of computational workflows, their sustainability and long-term usability. And provenance information can be used to avoid unnecessary computation using that job cache, and the FAIR principle can be specialized to computational workflows. Now, let's all make our workflow fair. Next step for the second part is we need to develop metrics and assessments tools for this that could be reused across the various workflow systems and languages. And finally, my thanks go to all the Galaxy collaborators that both work in Steers or outside of these things, especially for the job cache, Marius, as I mentioned earlier, Bjorn, all the Use Galaxy team, Paul, Raphael, and Frederick from BIB, involved in various levels of Steers and similar projects. And for the workflow fair part, Sean Wilkinson, Stian, and Carl from Manchester. And all the founders, so the European Union for Steers, BBSRC for supporting my work, and Elixir for supporting me traveling here today. And thank you for your attention. Happy to have questions. Questions? No further questions? Okay, find me around. Please, thank you again.